Example 3 in section 6.7. Here we have an example with repeated linear factors in the denominator. So by repeated, I mean we've got that squared there. And so it's technically meaning that we have x plus 1 times, oh, I missed the one. We have x plus 1 times x plus 1. So it's repeated, right? So that's important to take into account. However, each one is an individual factor, so if we break this into a partial fraction, we need to break that down as well. So the way we do that, let's go back to our first page really fast, is for each repeated factor, let's find it in this list, we actually list the linear factor without the square, and then we list it with the square. So then if it were a cube instead, we would list it with the cube. And if it were more than that, we would keep listing it for each individual power till we get up to the power that's on that repeated factor. And then for non-repeated factors, you would just add those into the problem separately. So let's see if we can make sense of this one. This one's just repeated factors. So we're going to set this up with 5x minus 1 over x plus 1 times x plus 1, right? Sometimes I like to write it out separately just so that I remember what I need to cancel and such. So we're going to have a over the factor by itself, and then b over the factor with a multiplicity of 2, basically. So since it's just squared, we stop there. If it was cubed, we would do a whole nother one with a cubed on it, but we don't need it because it's not cubed. All right, let's go ahead and use our same method, although this one's not going to work quite as well, but we still have to do the least common denominator method regardless of what other method we can use. So we're going to multiply by our LCD over 1, so x plus 1 times x plus 1, they both cancel out, and then x plus 1 times x plus 1, so those both cancel out. No, 1 cancels out, my bad. And then this one would be both cancels out. X plus 1 times x plus 1. I'm just going to write it this way. They both cancel out. Ta-da. Okay, so that leaves us with 5x minus 1. The denominator's gone. A times x plus 1. The other one's gone. And then both of them are gone, so it's just b. We actually, can we use a convenient x method on this? I guess we can to find b, but to find a it'll be a little trickier because there's no x value over here to turn that into a 0. So we might want to just go ahead and use the other method since we can't, or we can actually use a combination of methods if you want. Here, let's do that. I think I like that idea. So I'm going to let x equal -1, so that's a negative. 5 times -1 minus 1, so that's a -6, equals a times -1 plus 1, so that's 0, plus b, so b equals -6. That's nice to know, right? So we'll just kind of set that aside. Okay, now let's go with the other method we learned, which is where we gather up our terms. So we're going to go 5x minus 1 equals a times x plus a times 1 plus b. But we already know what b is. Would it be okay if we just go ahead and plug in b? Since we already found it. I don't see why not. So b is -6, so instead of b, I'm just going to put that -6 in place of b. Ta-da! And go from there. So let's go ahead and gather up our terms. So our x terms will be 5x equals ax. Well, I think we've got it solved right there. We could probably stop. So 5x equals ax, which means that a equals 5. We could keep going just for fun if we want to, but I don't think there's a need. So constants would be -1 equals a minus 6. Well, what would a have to be to make this true? Does 5 work? See, this is how we can kind of verify it. 5 minus 6 is -1. That still works. So a equals 5. All right, that was a fairly easy problem. If we hadn't been interrupted by exhaust fumes in our classroom, we could be done. We could have easily just done this problem. So a is 5. over x plus 1. Don't ever forget to write out this last step. It's easy, and I've seen students lose points on final exams for forgetting to write out, yay, I found a and b, I'm done. Yep, not until you write it out. B over x plus 1 squared. Ta-da! Nice, easy problem. Let's go to the next one. Actually, I like to keep my videos short. I don't know if you mind